Hey there everybody, it's Mr. Sheeline. This is going to be the video covering Unit 3.4, Part 2 notes. So this is going to be the acid and hydrate compound naming. Okay, so the video before that you would have watched would have been the formula creation. Here we're going to be taking the chemical formula and creating the name for both acids and hydrates. So similar to you know, pretty much what we've been doing with ionically bonded compounds and covalently bonded compounds. We'll make the chemical formulas first, and then we'll name them second. And pretty much all the rules are just the reverse of, you know, or the rules for naming is just the reverse of making the formulas. So same thing here. So let's just get right to it. So when we're naming acids, here's what we need to do. We need to make sure it's an acid. So remember, when we're given the name, what identified it as an acid is that acid was at the end of it. Okay, but this time what's going to identify it is that it begins with a positively charged hydrogen ion. Okay, so if it's got a hydrogen ion, a positively charged hydrogen ion in front of it, most likely it is it's going to be an acid. Now the only exception here, of course, is going to be H2O, but really is it an exception when H2O isn't an ionically bonded material, that it's actually a covalently bonded, more or less a covalently bonded material? I'll let you be the judge. Actually, I won't. No, it's really not an exception, to be fair. But it's just to say that, yeah, H2O, it's not an acid, obviously. So is the anion monatomic or polyatomic is the next question you should be asking yourself. So if the anion, okay, because remember your cation is always going to be hydrogen, positive hydrogen ion. So your anion, if it's monatomic, the acid name begins with the prefix hydro. Okay, so we're going to begin by naming this guy with hydro. If it's polyatomic, the acid name has no prefix. Okay, it has no prefix. So this is, again, polyatomic. So we saw that with like sulfuric acid. Okay, we saw that with nitric acid. You'll see that with phosphoric acid. It doesn't get the hydro because it's a polyatomic ion, where polyatomic ions like hydronitric acid or hydrophosphoric acid, they are acids where it's a monatomic ion. So we'll see what that looks like. So in this case, we're going to be changing the, you know, for covalently bonded compounds and ionically bonded compounds. Remember, we would change the last few letters. We would get rid of the last 3 or 4 letters, and we would replace them with IDE. We're doing that here, only instead of IDE, it's IC. Okay, with IC, and we'll practice that. And then you're going to add acid at the end of the name. So let's take a peek here at H2S and then H2SO4. So let's walk through those steps. So identify it as an acid. Well, I can see that it's H2S, so that must mean then if it's got hydrogen at the beginning, that must be, both of them have hydrogen at the beginning, this must be an acid. Okay. So I'm going to then ask, is the anion monatomic or polyatomic? What looks like my S here is monatomic. So I'm going to start writing out hydro, okay, because again, my anion here is monatomic. That S is monatomic. This guy right here is monatomic. Okay, so I'm going to start with hydro. Now I'm going to start writing out, and I'm going to identify what it is. It's sulfur. So I'm going to put sulf, and then I'm going to think, well, how would I change sulfur? Almost think of it like this. So if this were an ionic compound, this would be like sulfide. So we're going to get rid of the IDE and let's put IC. Or sorry, no, we're not going to do that. My bad. Oh my goodness. No, we're not going to do that. Why would I say that? We're going to write out the whole thing. I am so sorry. I got myself mixed up there. I'm trying to make it easier for you. I'm confusing you even further. No, it's going to be this. Sulfur, put the IC. Hydrosulfuric, add it with acid. Double check that. Boom. Good. Okay, too easy. Let's take a look at the second one here. So we've got H2SO4. So obviously it's an acid. Is it monatomic or polyatomic? It looks like it is polyatomic. That's sulfate right there. So if it is polyatomic, it doesn't get a prefix. Okay, so it's as if writing out sulfur. Okay, could have put add my IC, sulfuric, add acid. Ooh, acid, not aid. And that's it. Okay. So let's try these examples out. So I'm going to do 2 of them for you, and then I want you to complete the other 2 on your own. So as soon as I'm done with these 2, pause the video, try these 2 on your own. Play the video again, and see if you're right. So let's take a look here. So again, we already know this is going to be an acid because we see the H's out front. Now, is this monatomic or polyatomic? It looks like it's polyatomic, so it's not going to get a prefix. Specifically, what is it though? It's phosphate. So if it's phosphate, okay, in this case, if it's phosphate, I'm going to get rid of the ATE at the end, and I'm going to, because its name is phosphorus, I'm then going to borrow the name, because its name is phosphate, which heavily relies upon the word phosphorus, the name phosphorus, we're going to take the word phosphorus. Jeez. Now, this is where I'm going to give a lot of leeway again. Like, these should be acids that you're familiar enough with that you should know, like you should recognize or hear, like, you know, phosphorus acid doesn't sound right, but phosphoric acid sounds right. Okay, which would you would be exactly correct. We would drop the US at the end and add the IC. It's not terribly obvious for sulfuric or hydrosulfuric. Make your best judgment. If it's close enough to what the answer is, I'll accept it. Let's just say that. Okay. Here's what I won't accept. If you just put phosphorus, if you just put phosphorus acid, I won't take that. You need to try. It needs to have an IC somewhere. Okay. So phosphoric and then acid. That one's done. Let's try out this guy. HF. So I'm going to see here that yes, it's an acid. Is it monatomic? Yes, it is. So it's going to get the prefix hydro. And it looks like this is fluorine. Okay. Now again, this is where it's. Let's sound this out. What sounds more correct? Does hydrofluoric acid sound correct, or does hydrofluorinic acid hydrofluorinic acid? What do you think sounds correct? Okay, you tell me. Hopefully you said, oh, hydrofluoric acid sounds pretty much on the dot, which it is. It's hydrofluoric acid. Okay. So try these 2 on your own. See if you can get them. Okay. Pause the video here. Try them out. Play the video when you're all done. Okay. So again, looks like it's monatomic. So we're going to start off with hydro. And it looks like my monatomic here is going to be, my monatomic here is going to be nitrogen. And because it's nitrogen, I'm going to start writing out. Start right out nitrogen. And again, this is, I can't stress this enough. Try to sound this out. What do you think? Nitrogenic acid. That doesn't sound right. Nitrogenic sounds kind of weird. What else? Hydrogen. So hydronitroic. That doesn't sound right. Hydronitric. Oh, that sounds kind of good. Hydronitric acid. And you'd be 100% correct. Hydronitric acid. Okay. And then this goofy looking guy down here. So, of course, that H is there, but you have this big old mess. So it's not going to get hydro. Well, what is it? Well, we'll look it up. We'll see that it's acetic, or it's acetate. Pretty much just ruined it for that surprise for you. So there's acetate. So acetate, where would I replace what would I replace the IC with? well, probably wouldn't be, we wouldn't just keep acetate and add IC. That'd be acetaic acid. That doesn't sound right. How about we just replace the AT with IC? Acetic, and add our acid at the end. Easy enough. Relatively speaking, easily enough. Again, get close enough to this and I'll give you points. But again, you have to add the IC somewhere and you got to have acid somewhere. Preferably, if in most cases, we're going to be working with the same acids over and over again. And by the time next week, by the time you take the test, we should have this golden. Okay. So for the most part, I'm not even going to hide this from you now. Identify the formula as a hydrate. Here now we're looking at hydrate, so they all end with H2O, obviously, well, the coefficient and then the H2O. Use regular naming rules for the first substance, and the first substance is usually ionic. Then use the prefix that represents the coefficient number in the front of the H2O, so that's going to be, we've got to be right now. Now we've got to start right now, again, all of those prefixes, okay? And then after the prefix, add hydrate. So as an example here we've got iron oxide, iron 1 oxide, tetrahydrate. Boom, right there. Oh my God, so easy. It's just, it hurts how easy this is. So let's take a look here. So I'm going to separate all these bad boys, but again, I'm only going to do these two, and then I want you to do the other two on your own. So I'm going to go through these right meow. So CaS, so that's going to be calcium. Okay. Now again, because it's like an ionically bonded thing, or sorry, compound. So it's going to be calcium and then sulfide, calcium sulfide. You should just, hopefully by now you can just look at them, know that the first one is going to be normal, so calcium. The second one's going to be a little different. Well, that's sulfur. Well, what's sulfur's ionic name? Sulfide. So calcium sulfide. And then here we just have to figure out, well, what's the prefix? Well, the prefix is hexa. And then H2O, hydrate. Boom, done. Let's take a look over here. But here's the tricky part. Remember, it's which you'll see down here in the next two after this one, is that remember we still care about transition metals here. So transition metals will still get their parentheses and their Roman numeral, like iron up here. So don't forget about that. But we don't have to worry about it here. So aluminum, or as they say in the UK, aluminium. Okay. CO3, which we don't really need to know the 3 on the outside, but we know the CO3 is going to be carbonate. So aluminum carbonate. And then 2, dye, H2O, hydrate. Und mein Gott, so easy. So there's 2. We did 1 as well. I want you to do these 2 on your own. Pause the video here, try them out, and then come back and see if you got them right. Okay, so now these 2 are going to take a little bit more work here, as you probably saw. So here I'm going to do some reverse. I'm going to be doing some reverse. That's crisscross here. So this is 2 negative because of course it's going to go up top. So if it's 2 negative for the oxygen, that means that we're good. Oxygen's charge is 2 negative. So it looks like it's going to be copper 1. So we've got copper 1 oxide. And it looks like we've got 9, so that's nona hydrate. Easy peasy. Here we've got iron. We've got some sort of iron, but again we've got to reverse crisscross. So I don't know what iron's charge is, but I know that phosphate's charge here is going to be 3 negative. Okay. So if that's 3 negative, and both of them aren't showing any other subscripts down here, that must mean then this is iron 3. Okay, so I've got here iron 3 phosphate, 5 penta H2O hydrate. See, it's again, it like hurts my heart how easy this is, because once you get into a rhythm, especially by this point, we should be getting into a rhythm where we can just look at we can just look at these things and we can pretty much just name them directly in our brains, and we just write them down. I'll just say, if you're at that point, just be careful, because again, you've got to make sure that you're catching any of the transition metals, because if that's where it gets tricky. That's where you might trip up, because these are easy. Here, you've got to take an extra step to make sure you've got the correct ion. So just be careful there. And then also remember, you need to make sure you know all of these prefixes for the test, because you will not be given those prefixes for the test. Okay. Other than that, guys, that is the notes. Those are the notes. Sorry, yeesh, English was hard. If you have any other questions for me, make sure you ask them. But if not, I will see you in the next one.